Okay, so we are going to start out by doing just some simple things. And I'm hoping that you see that the statements that you make in your proof, David, are like a conjecture. They are conjectures. And every conjecture that you make, you're giving it a reason. You remember at the beginning of this chapter, some of you made some terrible conjectures, right? And I even told you that. This is why. Okay? David, I think you were one of them. You want to make a statement. You want to make a statement that's going to help you progress to the next step. Okay? You don't want just something silly up there. Okay? All right. So, in this first one, it says rate BD bisects angle ABC. So we look at our picture, and what can we get from the fact that rate BD bisects angle ABC? Angle 1 and angle 2 are angle 1 and angle 2 are congruent. Very good. Okay. Now, what's my reason? Definition of bisected angle. Definition of angle bisected. Okay, good. So we can say angle 1 is congruent to angle 2, and that's by definition of angle bisector. Now, some of you struggle with what the reason is, okay? And one thing that you want to do is you want to go and look at what they tell you, okay? They're using the word bisect. That means something, okay? So go back and look at that definition. Or there might be a postulate or a theorem or another kind of rule that we learned, a property. It has to go back to that. You can't just say definition of congruent angles. Well, that has nothing to do with this, okay? It's got to relate back to what you're told. Okay, here's another one. It says B is the midpoint of AC. B is the midpoint of AC, David.
Segment AB is the segment BC.
Okay, so you're saying AB equals BC.
Reason for this definition.
Very good. Reason would be definition of midpoint. Now, wait just a second. Sometimes there's more than one thing that you can say. Okay? I heard somebody say AB plus BC equals AC. Okay, you could say that, but that really doesn't go back and reflect on the fact that it's a midpoint. Okay? I'm not saying that it wouldn't be needed in a proof at some point. Okay? But you're right, that is a true statement, but it doesn't really relate back to the fact that it's a midpoint. But I heard somebody else say something about being congruent. Could I have said AB is congruent to BC?
Yes.
Yes. Okay. And that would be by the midpoint theorem. Okay? The midpoint theorem allows you to state congruence. The definition of midpoint allows you to state equality. Well, I'm not a super big stickler about it. They both kind of mean the same thing, but technically you want to try to do things right. The equality is for the definition of midpoint, and the congruence is for the midpoint theorem. Now, you take a look at a couple of these. Said AB plus BC equals AC. That is a true statement, okay? But it's not really one that we want to state at this point, okay? And we've not really learned what this is called. We're going to learn that tomorrow. This is actually called the segment addition postulate, okay? And we will use that a lot tomorrow, okay? So it's good that you recognize it, just not really relatable to the fact that you were told that B is the midpoint of AC. Yes? David got that one right. Very good. Okay, now this one's easy. Okay, this is easy. I'll open this for you. You're given AB equals PQ. PQ equals XY. Conclusion AB equals XY. Okay, conclusion AB equals XY. What's my reason?
Transitive.
Transitive. Very good. Okay. I'm using a different format, so I gotta. All right, look at the next one. Now look at the words here. It says AD bisects BC. AD bisects BC. What is being bisected? ACA and CJA. Oh, the BC. What is being bisected? BC is being bisected. Okay? So this is what's being bisected. So what can we get from that? BD and DC. Very good. BD and DC are congruent. It has nothing to do with the angles. Everybody see that? Okay, the angle, it doesn't say anything about the angle in this case. The only thing that's being bisected is the segment. So, BD is congruent to DC, and then what would my reason be? Midpoint. Wait,
Bisector.
Definition of bisector.
definition of bisector. Definition of segment bisector. Okay. Jacob said something about midpoint. Okay. Yes, because after we state this, the fact that this bisects and that these two parts are congruent, I then can say that D was the midpoint, but that would be a step after this. Okay, and that would be by the midpoint theorem. Okay. David, unfortunately, you said definition of congruent segments. Okay. We use that when we go from equality to congruence, or congruence to equality. Okay. All right. Okay, let's look at the next one. Now this one's a little proof. Okay, a couple steps here. It says BD bisects angle ABC. Angle 2 is congruent to angle 3. Now when you do a proof, you want to look at the given, you want to go and mark up your picture, okay? Try to formulate a plan in your brain, okay? Sometimes you can get things from your picture, like vertical angles and linear pairs. We'll talk more about that on Monday, okay? So we're told here that BD bisects angle ABC. What can we get from that?
Angle 1 and angle 2 are equal.
Okay, they're congruent, okay? Angle 1 and angle 2 are congruent, okay? Then we're also told that angle 2 and angle 3 are congruent. Well, if 1 is congruent to 2 and 2 is congruent to 3, are 1 and 3 going to have a relationship?
Yeah.
Yes, they're going to be congruent by what?
The transitive.
They're going to be congruent by the transitive property. Let's write it down. I think you'll see it better when it's written down. Okay, so we have BD bisects angle ABC, and angle 2 is congruent to angle 3. That's given to you. Then from the first part of the given, we said angle 1 is congruent to angle 2. And you guys said that was by what? By transitive property.
Law of bisector. But the
Definition. Definition of bisector. Okay. All right. Now, you might be able to see this better. 1 is congruent to 2. 2 is congruent to 3. So, angle 1 is congruent to angle 3, and that is by the transitive property. Remember, there's not a substitution for congruence, only for equality. All right. Any questions on that one? Okay. One more. Okay. D is the midpoint, and this should be BC. D is the midpoint of BC. D is the midpoint of BC, and it says that AB and BD are congruent. And I want to prove that AB and DC are congruent. All right, so look at our given. What can we get from the fact that D is the midpoint of BC? That B and D and D and C is congruent. Okay, so we can get that these two guys right here are congruent, right? And then we're given that AB and BD are congruent. So can we make the connection that AB and DC are congruent? Yes, we can. Okay, so let's write this down. That D is the midpoint of BC, and AB is congruent to BD, and that's given. All right, now from the fact that D is the midpoint of BC, what did we say we could get? Okay, BD is congruent to what? DC. And what was that by?
law of bisector. Definition of bisector.
Didn't say bisector up here. What did I say?
Midpoint.
Midpoint. Okay, so the definition of midpoint is the midpoint theorem. Okay, it's the midpoint theorem. All right. So if AB is congruent to BD and BD is congruent to DC, what can I say?
AB is the least.
AB is congruent to DC. And that is true. Alright. So, the best way to get better at a proof is to practice them. Look at ones that are done correctly. Know your vocabulary and your rules, your theorems, your postulates, your definitions, okay? Alright. Now, on your worksheet, I want to make 2 corrections on here. I also want to remind you that you cannot assume anything, okay? Bad things happen when you assume. Like if it looks like it's a right angle, you can't just assume it. There has to be a little box there, or you have to be told there's 2 perpendicular lines, okay? Or you have to be told the measure of it, okay? You can't just assume. Just because one thing looks bigger than another, maybe not necessarily the case. Now, if there's a logical reason why it is, then you can assume that, okay? There's 2 things that I want to show you real quick. Okay, if you will look at number, right under number 2, where it gives directions for 3 through 7, notice that they just have definition of midpoint. They don't have midpoint theorem. And some of them really are the midpoint theorem, okay? So you can go ahead and put the definition of midpoint, but then you might want to write out there next to it just so you'll know that it's actually the theorem, okay? On next to the problem, okay? When you're doing the problem, some of them will require the midpoint theorem, but the midpoint theorem is not given as an option there. So what you might want to do is next to the problem when you do it, if it's not definition, if it's actually midpoint theorem, just write yourself one of those, okay? And then on number 7, I'm going to add this, on number 7, I'm going to add this under the second step. It might make it easier for you to see it, okay? I'm going to add this little 2B step there under the second step or the third step, okay? And I think it might make the rest of it easier for